We started off by finding the mass of our cart with the spring scale. After measuring height, we calculated our velocity. After we found our velocity, we used half mv squared to find our kinetic energy and mgh to find our potential energy. We added kinetic energy and potential energy together to find our mechanical energy. As you can see in both our chart and graph, our chart is right here, and our graph's below. You can see that the mechanical energy slowly decreased.
Yeah.
It still stayed about the same, but it was mostly the gravitational energy, it decreased, and while the kinetic one increased.
Okay, so this is an example about how we did the thing. So, to start off, we got a meter stick and we measured up to where this part of the wood meets, I guess meets the photo gate. So it was just from the table or the floor up to right there. And so for our first one, we had it at 82 centimeters. So we're just gonna say that that's at 82 centimeters. And so then we put the car all the way at the top, and then you let it go. Voila. So from that, we used the photo gate to find our time. So our time for the first one was, I don't know right on there. It was 0.1 something seconds. I don't remember.
It's on there.
It's on there.
0.0318.
That 0.0318.
And you divide 0.05 by our time to
Because
find your velocity.
0.05 is the little section on the cart that actually goes through the photo gate. And then from that, you find your velocity, your kinetic energy, 1/2 mv squared, and everything else. I don't know if are we supposed to do that.
I think that's it.
Did you do anything?
We backed up our claim with, as you can see, if you want to closely look at the graph and the chart here. Can you see it in the video?
See, as the height decreases, the kinetic energy increases and the gravitational energy decreases, and while the mechanical energy stays about the same, it does decrease a little bit.
So yes, the mechanical energy slowly decreases as height lowers.
Secret tunnel.